Good morning, students. Welcome in video lecture of electronic devices and circuits. We are discussing unit number 2, MOSFET and its DC analysis. In previous video lecture, we discussed the point as voltage references under the topic name as common MOSFET configuration. In that, we discussed the how the electronics component, that means resistor or BJT or diode, they are used for that particular developing the voltage reference circuit, and how the voltage reference circuit it is giving the output. That means voltage reference circuit's main concept is that it should give or it should provide the constant voltage, right? Irrespective of the, you can see that external sources, the external sources in the sense the sources which are affecting on that particular output voltage, and these voltage sources are reference sources, external sources are which are considered under the voltage reference as you can say that temperature, then the power supply, then the production process. These are again affecting, or they are giving the error in that particular voltage references. So independent on that, how the that particular voltage reference it is giving the constant voltage, that we discussed one. And along that BJT, you can see the transistor and diode, resistor, along that how the MOSFET it is configured as the that particular voltage reference circuit in that in various application, that we discussed one. That means how it can be configured one, it can that we discussed one. Now in today's this video lecture, we are going to discuss the next point as the principle of band gap reference under the main topic as the common MOSFET configuration. Now, as the name it is considered as the band gap reference, principle of band gap reference. Here the main concept of this particular band gap reference is that it to convert the signal from digital to analog or analog to digital, we require the reference voltage, right? And furthermore, it should be considered that any auxiliary circuit, its function makes to band gap reference one of the most important circuit in all mixed signal and radio frequency, right? So here, by considering the that voltage reference, it is not that much sufficient one for that any application, and for the any other mixed, or you can see that mixed signal or radio frequency systems, we require the additional circuitry, and that is nothing but the band gap voltage reference, which is most important circuit for this. So it is not a possible to make a precise conversion if voltage reference is not a constant, right? So that is the one thing. Another thing is that it is that in generic mixed signal systems have more than one voltage references. As a result, different voltage references are necessary. That means whenever you are considering the mixed voltage, mixed signal systems, at that time you have to consider the one more than one voltage reference. As a result, it is having the number of different voltage references which are necessary one. Now, all of them need to give the high accuracy and high solution for the high speed data conversion. They have to give that particular thing. The band gap voltage reference output value is not important, but it must be give a constant and accurate result or constant voltage, right? Accurate or constant voltage. It is the important thing. It must be tolerated as possible to the inherent any external non-ideal factors such as temperature, power supply variation, production process, that is most used, that is considered in that particular, you can see that voltage references as well as the band gap references. The most used band gap voltage reference circuits uses the either BJT or parasitic BJT, or having the op amp with the consideration of that in process of the CMOS concept or CMOS component, right? So this is the just first point about related to this particular band gap reference in that particular slide. Now, the band gap reference circuit is an important component to convert the analog or digital to analog the signal, right? Which is broadly used in a mixed signal and radio frequency systems, right? It is the main point. Now, the most BGR uses the bipolar junctional transistor to which is giving the or which is reduce the easily reduce the temperature dependence due to its having the ability of the temperature coefficient concept. And other common practice it is using the this particular op amps. See here what I want to say here. Whatever the BGR there, that means most BGRs, that means band gap reference circuits are there. They are using the BJT or the op amps. Here, main purpose of use of that BJT is that it is the working with the temperature dependence concept. That means due to its temperature coefficient concept, right? And related to that, the common practice is that use of the op amp. Okay, now see here another thing is I want to share with you people that here by using the you can say that this that CMOS technology in that particular BJT architecture can be implemented without using the use of the BJT. What I want to say here, without using the BJT, the CMOS technology can be implemented in a band gap voltage references. Now, here it is said that to accomplish this thing without compromising the specified voltage variation requirements with the that particular variation of the 1% of that voltage. See here, the CMOS can be used without the BJT in that particular band gap reference voltage, which is giving the voltage variation requirement with the 1% variation only, and compromising the specified that variation in the that particular all the variation voltages. So say suppose the band gap was for 1 volt 1.8 volt supplies which is having the 10% plus minus variation. This is the one consideration. Now for example here it is given as suppose the circuit which generates the output reference voltage of 605 0.865 millivolt with the variation of plus minus 3.325 millivolt. That is the thing. So 605.68 millivolt, whatever the reference voltage it is considered one. For that the variation is the plus minus 3.325 millivolt. And for which temperature range? For the minus 40 degree to 85 degree Celsius, which is giving the variation, which is considering the corresponding variation as the 1.09 percentage variation. Okay, this is the concept. So here the band gap principle of the band gap reference considered here in that BJT and op amp it is considered one. Apart from that, if suppose you want to implement the CMOS technology which is giving the variation up to plus minus 10% variation for the voltage of a 1.0 volt supply voltage. So this is the concept of this particular thing. Now exactly how the concept it is considered, see here with the reduction of the transistor size. Now as the technology it is increased one, there is a huge tremendous change in that particular electronics component it is happens one. So as the reduction of the size of the transistor, this reduction of the supply voltage, the more precise band gap reference circuits are needed one. More precise band gap reference circuits are needed one. For example, see here with 5 volt supply, a band gap should give the output voltage up to 2 volt having the 20 millivolt variation, which is the 1% error. This is the one example. Another is suppose 2 volt supply voltage is there. At that time, it should give the output as the 1 volt and having the 20 millivolt the variation, which is giving the error as the 2% error. Now, the aim is the to realize the all CMOS bands are in a having the good condition or giving the good performance. That is the aim is there. Now this is the thing. Now for the voltage references which are used generally in all in analog integrated circuits, the IC which is needs more than one voltage reference in order to avoid the signal degradation and to respect the different requirements of the voltage reference, right? So whenever you are considering the analog integrated circuits, you are considering the analog that particular whatever the integrated circuits you are considering one having the analog signals, then you are considering the voltage references. Now in that ICs, it requires the more than one voltage reference in order to avoid the signal degradation and to give the respect of that particular different requirement of the voltage reference. So their outputs can be predicted and needed to have a higher accuracy, so that their outputs can be predicted one and needed to have a higher accuracy one. This is the thing. Now the purpose of band gap voltage reference is to eliminate the, now see here main concept of this particular principle of a band gap reference. See, purpose of the band gap voltage reference is to eliminate all external factors and provide an output as constant, as accurate as possible. That means this is the one thing. There are several external factors like temperature, your supply voltage VDD, the processing variation, right? So something that after the IC production, the designer cannot predict this variation. So the BGR circuit must able to withstand with this source of the errors, right? This is the main, you can see that concept. Now the working principle of band gap voltage reference using the BGT can be, you can see that easily explained one. See here, when temperature increases, see when temperature increases, base to emitter decreases linearly and the thermal voltage increases linearly, which makes the output voltage V out approximately linear. This is the, you can see that simple, you can see that explanation. Now see here, in this slide I am going to show the one of the simple band gap reference using the parasite BJT. See here this figure. In this figure, you can consider, that means here it is considered that the MOSFETs as well as the op amps as well as the, you can see that transistors, all these are considered along with these particular resistors. Now here see these particular points, point VA and point VB. Here these 2 points are important one. Why? Because they are giving the constant current to these two transistors and having the same equal, you can see that voltages. And due to this, at the end, this M3 it is producing the reference voltage V reference, right? So here from the given figure, VA must be equal to VB, just I said that, which produce an equal current in each branch, and that current is proportional to the absolute temperature, whatever the temperature variation it is there. By considering that, that particular current should be produced one. Now VB is the difference between the VBE1 and VBE2. This base to emitter voltage, it is the difference between the whatever the voltage difference in transistor 1 base to emitter voltage and transistor 2 base to emitter voltage, and that is given as in the form of this particular equation as this particular thing. Now here in this equation, VT whatever it is shown is there, this VT is nothing but the thermal voltage, and this N is nothing but the emitter area ratio for that both transistors. Okay, and by considering that, here the band gap voltage reference, it is given as V out is equal to I1 plus I2 into R3, and this again this equation written as like this one. Now with an appropriate choice of this particular R3 R2, this ratio, and R2 R1 ratios, the variation of V out due to the variation of Vt, that means thermal voltage, and the variation of the emitter to base voltage with the temperature can be reduced one, can be maintained one, you can say that, or reduced one. This is nothing but band gap voltage reference, right, which is controlled by this particular ratio of R3 by R2 and R2 by R1, which is considered the variation is in these particular things. Okay, now here just I want to explain a few points under this particular consideration. So most band gap reference architecture uses the BJT and operational amplifier. This is the common thing. With this type of circuit, it is easier to reduce than whatever the external errors. Okay, that errors we can reduce one. Depending on the technology, BJT have the normally linear temperature coefficient. This is the one of the reason why usually it is used in the band gap reference architecture. Now, current must be equal in all three branches. The output temperature compensation produces two currents that are mirrored to output branches. Okay, in equation, that particular circuit you are considering here. Here, mirror circuits are considered one. Mirror circuits are considered, which are developing the equal current in that particular you can see that branches. Now, one of the this can be also obtained by using, or this also assured by this particular operational amplifier. Now, second concept with this particular band gap reference is that there are other similar architectures are there, but the all have the same goal, same goal. All are having the same goal. The to reduce the temperature compensation in order to make the P reference as the more precise as possible. Okay. Now, third one is the trimming technique, which is made to improve the output reference voltage. Right. This trimming technique also used one, which is used to maintain this output voltage constant. It is used to guarantee that after the corner simulation, the target performance is achieved one. And for this particular thing, whatever this technique it is used on analog circuit, and whatever the registers are implemented in that uh, analog circuit, which is having that particular values should be in a correct one, right? And proper selection, it is considered one for that right bits. So the number of bits that are necessary to use is proportional to the number of resistance needed one. That is the third consideration for this particular band gap. Now, see here, all whatever we are discussed now, we are considering the MOSFET, BJT, op amps, all that thing we are discussed one. Now, from onwards, whatever the slides, 2 or 3 slides I am going to discuss here, by considering only the CMOS technology. So here, band gap voltage reference technology, which is developed by using the CMOS technology without having the BJT and op amp circuitry. So see here this particular figure. In that I shown here the circuit having the all the only MOSFET devices, and by using that MOSFET device it is developed one, right? So here MOS transistors are used one, standard transistor used one, and which is considered the providing the different voltages with having the this particular VDD. So this M1, M4 and M6 it is having this equation for this particular VDD. This particular VDD which gives the relation of this M2, M5 and M7 voltages like this, and this particular M3 and M8 with along this R2, it gives this particular relation of this particular voltage of this VDD. So this equation it is shown here. See this reference point or node point VA and node point VB, it is again related to this particular two equal voltages as VR1 plus VDS M6. See this M6 and the voltage of this particular M7. So these are related to this particular this point, and they have to equal voltage to produce the equal current, right? As shown here in this particular thing. So remember this M1 and M3 and M4 and M5 along this particular M6, M7 and M8. Now M1 and M3 are the current mirror as I showed said already earlier one. M4 and M5 forces a node A and node B should provide the equal voltage, right, in order to stabilize that current behavior with the corner, right? That is the thing with the variation of the VDD. And register R1 and R2 in that particular figure, which implement the temperature compensation. And the transistor M6 and M7, they produce the voltage they produce the current, circuit current, and makes the possible to that particular MOSFET emit to stable the voltage irrespective of the variation of that particular VDD. That means this emit, it is providing the free reference output, which is again making the stable with consideration of this particular variation of this particular VDD by this particular M6 and M7. So this particular V reference, it is given by this equation. Now the resistance values varies from that particular corner to corner, as well as the ratio of this particular R2 and R1, which is also maintained one. So trimming it is done with the correct of this particular R2 and R1 ratio calibration. The output voltage reference is not important, but can be any value. Output voltage will be used to produce a voltage reference of any value in another circuit before the being used in either analog to DC converter or DC to analog conversion, or in any auxiliary mixed signal in a systems. So this is the, you can see that concept of this particular band gap reference voltage. See here, I already said that output voltage is not the, what exactly output it is giving is not the important is that to maintain the constant voltage, and this all the things are done by this particular, you can see that whatever the M1 M3 that current mirror circuit, and M4 M5 which is forcing the node A and node B as the constant voltage to stabilize the circuit behavior with the that particular variation of VDD. This R1 and R2 implement the temperature compensation. This R1 and R2. So by considering the ratio of R1 and R2 and the trimming concept of this particular R1 and R2 calibration, the output of that particular V reference, it is used for the voltage reference for the various analog conversion system, that may be analog to digital conversion or digital to analog conversion or any mixed signal systems. So this is important thing about this. You can see that MOSFET technology, which is implemented as a single device, single, but all it is used in all entirely circuitry for that avoiding the use of the BJT and op amps. Okay, for the getting the reference voltage at the output side. So this is the all about the this particular principle of a band gap reference. Point. Students, if you are having any query related to this, you can ask me anytime. Be in touch and study well and be safe. Okay, so you can ask me any error or anything related to that particular thing. You are having that particular, any, not error, any doubt, right? So any doubt you can ask me anytime. Okay, thank you once again.